Question 6. The diagram shows a circle C of radius r where x is greater than 0 and y is greater than 0 for all points on C. The least distance between any point on C and the x-axis is 80 units, and the least distance between any point on C and the y-axis is 5 units. State the coordinates of the center of the circle in terms of r. Now, since they said that the least distance between any point on C and x-axis is 8 units, that means we are going to go vertical. The least distance. Let me just do like that. So we are connecting these points here on this x-axis and all of that. But the least one is going to be this direct one here. Okay. And they said there is distance on any point and the x-axis. So it has to be that direct point here. From here to here. This one is 8. And then this one here is 5 units. Now, of course, from the circumference to the center, that is r. Even this one here is r. So meaning this center here, the x-coordinate is going to be this 5 plus r because it is the same distance here. And then the y-coordinate is going to be this 8 plus r. So we shall have the center here, which is equal to 5, or I can say r plus 5, then common r plus 8. Part B, given that the distance between the origin and the center of the circle is 15 units, find the value of r. So this distance here, this one here, is 15. So if it is 15, then we can use Pythagoras theorem. Okay, so this is what we are going to do. This is our triangle, 15 units. This one here is r plus 5. Then this one here is r plus 8. So using Pythagoras theorem, we can now say that r plus 5 squared plus r plus 8 squared should give us 15 squared. Then when we expand this one, it will give us r squared, then 2 times r times 5, that will be 10. So we get 10r, then square the 5, you get 25. Square the r here, that is r squared. Then 2 times r times 8, that will be 16r, and then square the 8, that is 64. Then you can bring this on this side, so that we form a quadratic equation, and that will be minus 225, which is equal to 0. R squared plus r squared, that is 2r squared. And then 10r plus 16r, we shall get 26r. And then this will be 25 plus 64, then minus 225. 25 plus 64 minus 225, that is negative 136. Negative 136. You can actually divide all through by 2. Here we shall get r squared plus 13 of r. Then here 136 gives us, when we divide it by 2, here we shall have a 6. Then remainder 1, so 16 divided by 2, that will be 8. That is the quadratic equation. Then I can put this one in the calculator to solve it straight away. So mod, and then we go to equation, which is 5. Then 3, that is quadratic, so we shall have the coefficient of r squared is 1. Then the coefficient of r is 13. Then the constant part is negative 68. This one will give us a 4, and then a negative 17. 4 and negative 17. So you skip some space and you say r is equal to 4 and r is equal to negative 17. Now bring this one here because you have to show the examiner that you solve the quadratic equation. So this will be r minus 4. We need to get the factors from which these roots come. Okay, so when this one comes this side, it will be a plus. So we shall have r then plus 17, which is equal to 0. But of course, the radius cannot be a negative, so that one is rejected. And we shall take our r, which is equal to 4. Part C, the point on the circle farthest from the origin is denoted by P. Find the gradient of the tangent to the circle at P. Now this point that is farthest from the origin, and it is on this circle, has to be here. You get this origin, you connect it to this circle, you pass it through the center, you go up to there. That will be the one farthest. All of these other ones here, when you draw them, they are going to be, their distance is going to be shorter. Okay, it is going to be shorter than for this one here. So that is what we are having there. Already we know that the tangent at that point P. So we need to draw this one here. That is the tangent. The tangent and the radius are perpendicular. So this is our point P here. And they want us to find the gradient of the tangent to the point, to the circle at P. So first of all, okay, we don't know the value of x here and the value of y. Now this line here, the gradient between any 2 points on the line is always equal, okay, is always constant. So already, if I use this line up to the center here, this one is r plus 5, and this one here is r plus what? 8. You see? So the gradient is going to be this one divided by this. It is the same gradient for this whole line. Okay? So we are going to have, and these two are perpendicular. So M1 is going to be equal to that r plus 8 over r, okay, r minus, r plus 5. Now M2, you know that for perpendicular lines, M1 times M2 is going to be equal to -1. So M2 will be -1 over this r plus 5 over r plus 8 over r plus 5, which can somersault, and we have the negative of r plus 5, then divide by r plus 8. Now we need to find the radius. Already the radius, we got it as 4. So that means gradient of tangent at point P is going to be equal to negative, then 4 plus 5, then divide by 4 plus 8. This one can be -9 over 12. We can simplify this one by 3, you get 3. By 3, then you get 4. So it's -3 over 4, which is also the same as -0.75.